Hi guys, here is part 2 of the practice test answers, and I will post this along with the first video. So here starts our short answer. So the first question is asking, write the sublevel electron configuration of the atom in the ground state. So what we have to get out of this description here is that it contains 4 protons, 5 neutrons. And so if we have 4 protons, that means we have 4 electrons, right? So if we are writing the sublevel electron configuration, we have 1s2, 2s2. Then it says state the name of the element symbol. So if we look at the periodic table, this would be beryllium, but I would just expect you guys to write Be. And so correct format and like spelling, that means B has to be capital and E has to be not capital. That's important for symbols. All right, state the atomic number and the mass number. So atomic number, we were given that with number of protons, so that is 4. Our mass number now, remember, is 4 protons plus 5 neutrons, which gives us 9. Okay, and this now asks, states the number of electrons in each shell in this atom in the ground state. So remember, we have 1s2, 2s2. And remember that shell is the same thing as a principal energy level. So in the first principal energy level, we have 2. So that's the same as in the first shell. And then in the second, we also have 2. So that is the second shell. All right, now moving on to this question about comparing models. So here you're going to have to, instead of having to memorize all the changes each person made to atomic theory, here's a nice table laid out for you, and you're going to have to answer the questions. And so from the first one, it's asking you, using the conclusion from the Rutherford model here, identify the charged subatomic particle that's located in the nucleus. Well, what do we know is positive and in the nucleus? In this case, it's just a proton. And then it says state the model that first included electrons as subatomic particles. So, first included electrons. Well, you have to think of who discovered electrons. Thomson. But also is the first conclusion that mentions negative charged particles. So this would be Thomson. And then now it's asking, state one conclusion about the internal structure of an atom that resulted from the gold foil experiment. So there's a few different things that came out of this. For example, atoms mainly, empty space. Or it has a nucleus. Or maybe that the nucleus is positive and dense. So lots of different options I would have accepted there. And state one way in which the Bohr model agrees with the Thomson model. Well, that would be the fact that we think atoms have electrons. Or maybe you state that in the sense that you say atoms have small negatively charged particles, or both models show an internal structure. Maybe it's the fact that actually both believe that atoms are neutral. So again, lots of things I would have accepted there. And the last 2 questions, which has to do with reading bright line spectra, and it's asking identify 2 elements in the unknown spectrum. So here is unknown. Well, we go and look. Well, let's see. The first, this first line here, looks like helium has that. So I'll check the other lines to see if helium lines are in the unknown. Here's this one. Yep, that's there. Yep, there's a helium line there, and here, and here, and here. So looks like helium is in fact there. And then doesn't look like sodium is, because there's 2 lines here and not 2 lines here, so it's not sodium. And if we look at hydrogen next, got one there, got one there, and it has these 2 here. So looks like hydrogen is there. And if we were to look at lithium just to make sure, then we would see that even right here, there's not a line, so it can't be lithium. So it must be hydrogen and helium. And then explain how a bright line spectrum is produced in terms of excited state, energy transitions, and ground state. We have talked about this a lot. And so, again, there's different ways that you can describe this, but you have to remember the overall concept is you have an electron at ground state that absorbs energy and moves to excited state. So this right here is talking, we've already hit on ground state, we've already talked about excited state, and energy transitions, that is what we're talking about when we absorb energy and transition to another state. So we're only partway done. So electron at ground absorbs energy and moves to excited state. And what actually produces the light is when, I'm going to pick up after